first thing we have to realize, since the law of cosines is the most difficult thing in the chapter, we have to know when to use it, because if we don't have to use it, we shouldn't. So we have to figure out when we need to use it and when we don't. This type of problem, we don't need to use it. Okay? The only time you're going to need to use it is if you're given an A and a B and a C. But in this particular problem that I have on the screen, if you're given two angles, you're okay. If you remember about the law of sines, you're looking to have like sine of angle A over side of A as part of your proportion. So you're wanting a measure of an angle A and a side of A to have both of those. Well, if I give you an A and a B and a C, I'm not giving you two of any variable. So that presents a problem. In this case, however, since I gave you two angles, you could find angle C really quickly by subtracting from 180, and now you have both C's. So this problem does not necessitate the law of cosines. In fact, I think you did problems like this last section. This type of problem does necessitate the use of the law of cosines, because you have an A and a B and a C, but there's only one angle. So the general rule for when we need to fire up the law of cosines is, I've given you an A and a B and a C, whether it's, I haven't specified angle or side there, giving you 1A, 1B, 1C, and only one angle or no angles. If that's the problem that I've given you, you need to use the law of cosines. Okay? The law of cosines is painted on the wall. It's also up on the screen. The letters, although you have to have things kind of in the right order, the specific letters are not crucial. We're not always finding angle A. Or if you look at the wall where it says the law of cosines up there by my shorts, we're not always finding angle C. It depends on the problem. Okay? But what is necessary is the bookend letters A and A. Those need to be the same. And that's the only two places where that letter appears in the law of cosines. And everything else is just the other two letters. BC, BC. Or in the case of the wall, the C's are the bookends, and then AB, AB. And usually if you're looking for something, it is either going to be, if it's a side, it's going to be the left side bookend variable. Or if you're looking for an angle, obviously it's going to be the only angle variable in the whole law of cosines, that big letter at the end. So if you're looking for something, you put it in a bookend. Somebody knocking? Okay, so in the one I gave you, we have angle A is 38.
Quincy's out there.
So here's the problem I gave you at the beginning. Angle A is 38, side B is 6, side C is 10. And we're going to look for the side that's missing, which would be side A. Okay, and so we're looking for side A, so I'm going to make that left side A my variable for the problem, and I'm going to fill in numbers for everything except that left side A in the law of cosines. So I'm going to fill in values for the B's and the C's and the big A. So when I do that, I'm just putting numbers into the law of cosines, which you never have to memorize. It's either on the wall, or I actually put a version of it, I believe, on your test. So you never have to memorize it. You just have to know when to use it and how to use it. And you'll see that A squared is equal to a number. All that stuff on the right side is number. You just have to get it right. So we have that. And we have that. A mistake that kids make all the time at this point is they want to write 16 cosine 38. That is not correct. Okay? Because it's multiply between the 120 and the cosine 38. So order of operations says you have to multiply 120 times the cosine of 38, then subtract it from 136. If you type it into your calculator, it should do it correctly. But just like you can't take 5 minus 3 and then multiply that answer times 4, you don't take 136 minus 120 and then multiply it by cosine 38. That's not how it works. So using a calculator, I get a squared equals 41.4. Square root. The square root, I get 6.4 for my side. At this point, I have enough information to use the law of sines. You should never have to use the law of cosines more than once in a problem, because what it does is it gives you enough information so now we can use the law of sines. We now have two things left to find: angle B and angle C. You always want to find the smaller angle when you have a choice. Okay? Here's why. Obviously, you would agree with me that triangles could potentially have an obtuse angle. Right? A triangle could have a 130-degree angle. Okay? Well, if we're going to use the law of sines will not find obtuse angles for answers. It just won't. It's limited. It has a limited scope of answers it will find, and one of its restrictions is it won't find obtuse angles. Okay? So, you can only find acute angles. Well, how do we make sure that we're only finding acute angles? Find the smaller angle. And then to find the larger angle, we'll just subtract from 180 once we find the other two. Okay? So we want to find the smaller one, which is, what was it, B? So sine of 38 over 6.4 equals sine of B over 6. Cross multiply. When I do my work here, I get an angle of 35 degrees. I just did 6 times the sine of 38, divided by 6.4, and then took the inverse sine of 0.5772. Inverse trig functions we've been working on all chapter. And I get an angle of 35 degrees. And then subtracting 38 and 35 from 180, I get that the third angle is 107, which we would not have been able to find using the law of sines. So with 3 sides, let's find the smallest angle. So that means that your bookend variables are going to be your smallest side, which would align to your smallest angle. Once again, it doesn't matter what angle you find when you're using the law of cosines, but if you just want to keep the same thought process as you do with law of sines, if you always find the smallest thing, you're going to be fine. This is kind of a difficult calculation because there's little things in here that make you want to screw up. Okay, there's big numbers for one thing. You're probably going to need a calculator. So my first calculation looks like this. Now, everybody will look at that, and the first thing you're going to want to do is subtract those 4,000 numbers. Because they look very subtractable. Because that would make things much simpler. But they are not subtractable. Because for the same reason as last problem, one of them is being multiplied by a cosine A. So the order of operations says you've got to multiply this 4472 by cosine before you can subtract. So these two, it ain't going to work. So you first need to subtract the 4553 over to the other side. Get that over there. And then, since the negative 4472 is being multiplied by cosine A, we will divide. And so cosine A is some sort of decimal, 0.8032. Inverse cosine of 0.8032 is approximately 37 degrees. Now that we have one of those angles, we're going to find the next smallest angle, which would be angle C, because that side is smaller. So we can set up a law of sines using angle C. And you can do this work on your own if you want. That's 57 degrees. And then subtracting from 180, that would give you 86 degrees, just subtracting the 37 and the 57 from 180.